All right, guys, this video is on Unit 1A quiz, Form C, and I'm going to be doing page 2. Okay, some of you guys were stressed out about this problem because this was a no calculator portion of the quiz. Okay, but you really just didn't need a calculator. You have to understand that these are inverse operations or opposite operations. Just like the inverse operation is subtraction, right? These undo each other. The inverse operation for this one is division. Okay, the inverse operation for squaring something is square rooting something. These are opposite operations. They undo each other. So if you square a square root, those cancel out, and that is just 17, right? 17 times itself. Well, that has to be a perfect square, right? The square root of 289, some of you guys were leaving this as your answer. The square root of 289 is 17 because 17 times 17 equals that, all right? Moving over to this situation right here, we have addition. Okay, in order for you to add these, they're going to have to be like terms. Notice that at this point in time, they're not like terms, but maybe when we simplify, they will become like terms. You can divide out 4. Okay, the square root of 4 is 2, so we're going to bring that out to the front. And last but not least, we're going to combine the coefficients. Well, guys, -2 plus 2. -2 plus 2, that is nothing. 0 is your answer. These cancel each other out. This is the negative version of the number. That's the positive version of the number. Therefore, they are canceled. Okay, moving into your true or false section. Okay, one thing I want you guys to read is directions. You must write out the entire statement to receive credit. Some of you guys are putting just T's and F's, and some of y'all, your T's look like F's. So you have to actually follow directions so that way I can give you full credit. The number 7.45 is a rational number. This is true. Okay, and the reason why is that's a terminating decimal. Okay, if it's a terminating decimal or a repeating decimal, it's going to be considered rational. All right, the number 3 pi minus 3 pi is irrational. Well, let's simplify this. 3 pi minus 3 pi is 0. If you have 3 pi's and I take away 3 of them, you have nothing. Just like in this example up here we were talking about. Okay, so is 0 irrational? No. 0 is one of our whole numbers or integers, which we know fall underneath the rational category. It's terminating. Okay, let's go to the next one. The product. Product means multiplication of two rational numbers. So rational times rational is sometimes irrational. We're asking ourselves if this is true or not true. Well, let's just do some cases. I don't know, 5 times 5 is 25. Well, that's rational, so that doesn't work. I honestly can't think of a case, guys, where you take two terminating numbers, okay, or repeating decimals, and when you multiply them, it becomes irrational. So this one, the product is sometimes irrational. That's false. I can't think of a single case that would make this statement true. All right, the sum. Sum is addition. The sum of a rational number and an irrational number is always irrational. All right, so let's just think through an actual case. 5 plus the square root of 3 is irrational. You actually can't even combine those. I think this statement is true. I can't think of a case like this that is not true. And if you can think of one, come talk to me about it. But I cannot think of one that would make this statement false, okay? All right.